Today we're going to explore how angles interact when two lines intersect, specifically when we have a pair of parallel lines cut by a transversal. Vertical angles happen when two lines of any kind intersect. So let's look at GC and AM. Four angles are created when this happens. There's four angles, but two pairs of angles that are important. The angles that are directly across from each other are congruent. That means that they are equal. So ABC is congruent to GBM. ABG is congruent to CBM. So we have this pair of this angle is congruent to its opposite. These are vertical angles. They're directly across from one another. ABC and GBM are congruent as well. There's ABC, there's GBM. They're vertical. They're directly across from each other in that pair or set of four angles. In this example, we have two parallel lines. Line AM and line EI are parallel. We know that because they're marked with those arrows in the middle. So we have two parallel lines. This means that they do not cross. They're like train tracks. The transversal in this case is any line that intersects a system of lines. So we have two parallel lines, AM and EI, and we have two transversals in this case, line GC and line LJ. They are crossing both of the lines in the system. When we do this, it creates a whole set of congruent angle relationships, only when we're taking parallel lines and cutting them by this transversal. One of these relationships is called alternate interior angles. This is a pair of angles on opposite sides of the transversal inside the two parallel lines. These angles are congruent. So they have to be on opposite sides. So alternate in this case means opposite sides of the transversal. That's the line that's cutting through the two parallels. They have to be inside of the two parallel lines. That's what interior means. When we know we have these two angles, we know that they're congruent. So angle ABG is congruent to CFH. Those angles, so ABG and CFH, are inside, so interior, inside the parallel lines, and they're on opposite sides, alternate, so opposite sides of the transversal. We could also look at EFB and GBM. So these two angles, EFB, they're on opposite sides of the transversal, and they are inside of the set of parallel lines. Alternate exterior angles follow the same rule. It's a pair of angles on opposite sides of the transversal. That's where alternate comes from. Exterior means they're outside of the parallel lines. If you have a pair of angles that are outside of the two parallel lines and on opposite sides of the transversal, then you automatically have congruent lines or congruent angles. This is like angle ABC and angle GFI. They are both on opposite sides of that transversal, so line GC. They are on outside of the parallels, so these two angles are congruent. We could also say that angle CBM and angle EFG are also congruent because they are alternate exterior. They're on opposite sides of the transversal and they're outside of the parallels. Another relationship is called corresponding angles. This is when we have a pair of angles on the same side of the transversal. One is inside, one is outside the parallel lines. In this case, the angles are congruent as well. So angle ABC would be congruent to angle EFB. They are on the same side of the transversal. One is inside, one is outside. These are called corresponding angles. Essentially, if you moved the bottom parallel line up and overlapped it with the top one, these angles would line up completely. We can also look at CBM, not GBM, and CFI, these are also corresponding angles. They're on the same side of the transversal. One is inside, one is outside of the parallel lines. Again, these would overlap. If I moved that red angle on top of that purple angle, they would overlap completely. They are congruent. Consecutive angles are a pair of angles on the same side of the transversal inside the two parallel lines. These add up to 180 degrees. So I have angle ABG and angle EFB. These are consecutive angles. They're on the same side of the transversal and inside of the parallel lines. They add up to 180 degrees, so they're complementary. We can also look at angle GBM and angle CFI. Those add up to 180 degrees. They are complementary. They're on the same side of the transversal, both inside of the pairs of parallel lines. Another relationship is adjacent angles. This is when you have a pair of angles on opposite sides of the transversal, inside or outside the two parallel lines. These add up to 180 degrees as well. So these are also complementary. So angle ABC and angle CBM add up to 180 degrees. We've also seen these angles called linear pairs or simply complementary angles. They're two angles that are right next to each other that form a straight line. I know they form a straight line because they're on that parallel line, so that has to be completely straight. Angle EFC and CFI also are adjacent angles. They add up to 180 degrees. They're complementary. So whenever you see two angles that compose or add together to make one straight line, these are complementary angles. We also can call them adjacent angles. 90% of solving problems with parallels cut by transversals involves identifying and just labeling the heck out of your diagram. It's like playing detective. Once I know one piece of information, there's not one correct next step. It's all about finding the missing angles. I may not be able to answer the question right away given the information I'm given. I may need to label up the entire diagram. So if I wanted to start labeling every given angle here, I know that this angle is 130 degrees. That is a vertical angle. So ABC and GBM are vertical, which means they're congruent. So that means that GBM is also 130 degrees. I can use the original angle and its corresponding angle to find 130 degrees and 130 degrees. So all you do is continually identify and then use that relationship. Either they add up to 180 or they are congruent. GFI and ABC are alternate exterior. They're on opposite sides of the transversal and outside of the parallel lines. So that means they're congruent. We have ABG and EFC, which are consecutive angles. So they add up to 180 degrees. So if I know that EFC equals 130, ABG I do not know, and 180 degrees is the total, I just need to solve that one-step equation. 180 minus 130 gives me 50 degrees. Using that piece of information, I can now find the remaining angles. On your own, solve for those remaining angles.